Hey, it's Christiane. We're going to talk about a second kind of continuous probability distribution now called the normal probability distribution or the normal curve. Sometimes you've probably heard about it referred to as a bell curve because it looks like a bell. On the left, you'll see the problem that we're going to work through. So let's read it out loud. As an aside note, I often have my students read problems out loud because it slows you down and helps you find the key information. The Camp family has twins, Rob and Rachel. Both Rob and Rachel graduated from college 2 years ago, and each is now earning $50,000 per year. Rachel works in the retail industry, where the mean salary for executives with less than 5 years experience is $35,000 with a standard deviation of $8,000. Rob is an engineer. The mean salary for engineers with less than 5 years experience is $60,000 with a standard deviation of $5,000. Compute the z-values for Rob and Rachel and comment on your findings. All right, you can see here that I've underlined what I thought was important information, and then I started right away by making drawings. Drawings will help you to really visualize what's going on. So here you'll see that this is Rachel's graph, this is Rob's. On Rachel's, in her industry, the mean is $35,000, standard deviation is $8,000. She makes $50,000, so you can see that she is above the mean. Don't worry about the rest of this stuff right now. I will explain that as we go through it. Here's Rob. So in Rob's industry, the mean is $60,000 with a standard deviation of $5,000. He earns $50,000, which is below the mean. Now let's look at this. Here, up and down the middle is the mean. To the left of the mean is half. To the right of the mean is half. Same over here. Here's the mean. On the right side of the curve, we have half of the curve, and on the left side of the curve, we have half. I know that seems very obvious at the moment, but it really does come into play. All right, so let's start with Rachel, and we're going to calculate the z-value of where she lands on her normal curve. Down here, you'll see the z calculation, the formula. So z equals x minus mu. So x is what she earns, and then mu is the mean. So we have $50,000 minus $35,000 over $8,000, the standard deviation. Plug all that into your calculator, or if you're really smart, you can do it in your head, and you come up with 1.875. That's a z-value. So we need to look that up on the z-table. So come back over here to the z-table, which is in the back, very back flap of your book. It's also Appendix B. So we go to down here, hit the first part of z. We need to go down to 1.8, which is right here. And then we need to go over to 0.7, kind of 0.8. So let's go here, 0.4699. This is the area under the curve associated with the z-value of 1.88. Remember, when we talked about uniform distributions, I told you that area is the same thing as probability, and this is telling you the area under the curve. Before, when we were doing uniform distributions, it was just base times height. But with these normal distributions, it's much harder, so they've come up with these tables for us. You can be very thankful for the statisticians that have gone before us. All right, so we're going to take this 0.4699 and whoop, put that right here. So I know the area under the curve between 35 and 50 is 0.4699, or about 47% of the curve is right here. Now, it doesn't look like it the way I drew it, but I didn't know what it was going to be when I was drawing things. So here's half of the curve. Here's another 47% of the curve. So what does that mean? Well, if you take 0.5 plus 4699, you get 0.9699. So if you add these two together, you'll see that 97% earn less than Rachel. So she's doing very well for herself, isn't she? We could also see this 47% earn between $35,000 and $50,000. So between 35 and 50,000, that's 47% of the workforce. Okay, let's look at Rob. Rob earns $50,000 in his industry. The mean is 60. Where does he end up? Let's calculate his z-score. 50,000 minus 60,000 divided by 5 is -2. So let's look up that -2 on the z-score. Don't worry about negatives or positives. We're just going to find the 2. 2.0. So we just go right across here. 0.4722. Come up here, put it on my graph. 0.4722. So 47% of his industry, almost 48%, is right between $50,000 and $60,000. 50% is above $60,000. So what does that tell us? Well, if we add these two shaded parts together, 0.5 plus 0.4722, we get 97, almost 98% earn more than Rob. So he earns the same amount as Rachel, but compared to his industry, not doing quite as well as Rachel's doing. We also know that 48% of his industry employees earn between $50,000 and $60,000. 47% is right here. So that's the way a normal curve works, finding the area of the curve and the probabilities associated with that.